Welcome everyone. Today we have our another new episode, and this is very important because we will discuss on IoT, Internet of Things. For Industry 4.0 development, IoT is very important. We have our world famous speaker, Professor Rob, Professor David Smith, Mr. Kumar, Mr. Joy Rahman, Professor Donalds, and Mr. Marshall. First, I would like to give chance Professor Rob for discussing Internet of Things.
Sure. IoT, which is the acronym for Internet of Things, came out of a series of efforts having to do with both industrial and home automation. Prior to the Internet of Things, there were two platforms that were somewhat predominant. One was the initial point like X10. It was the X10 platform for homes and an Echelon for industry. And then IoT took off, and everybody kind of threw out everything that had happened before, and we started all over again, and a bunch of new companies cropped up. One of them, for the home, Insteon, looked very promising, but this last week it collapsed, and it showcases some of the weakness with regard to the Internet of Things, which really circles around the concept of interoperability, common management, open APIs, and way too tightly tied to largely to standards that are owned by individual companies, not open standards. We do have a series of standards that the industry could use, but they don't use them equally or well. And so the difficulty is that almost every IoT project is by nature very proprietary. And one of the big issues with regard to IoT is, where does the intelligence reside? Initially, the intelligence was going to reside centrally, but that created huge problems with regard to lag and response time. And so it has since moved to a largely distributed model, or a model that is spoke and hub, where you have an intelligent hub, and then the spokes and items at the end have limited intelligence. That's been somewhat problematic as well, because you need to be able to push down updates, patches, and firmware replacements on a regular basis and in an automated fashion, because they're now, when you say the Internet of Things, we're talking about millions of things moving to hundreds of millions of things, moving to trillions of things in the future. So it has to work in an automated fashion. Otherwise, if you have to touch everything to update it, you quickly will stop doing the updates, and then your Internet of Things becomes a security hazard waiting to happen. It's an underlying concept that we often focus on as a solution looking for a problem. In most projects, you should start off with what the requirement is, and the requirement then should feed into what the solution is. Sadly, like a lot of efforts, Internet of Things kind of became its own. It had got a fire underneath it, and it started to drive forward without a clear understanding of what it was you wanted to accomplish. And largely, another issue is the different groups deploying the sensors, which is largely what the Internet of Things is made up of, have different agendas, often have different budgeting procedures, and unaligned requirements. And so you get your security organization that is pushing out connected cameras and locks. You have your manufacturing organizations also pushing out cameras and motion sensors and spatial sensors, and then you've got your IT organization that's pushing out their series of devices, be they dedicated devices to watch for attendance, or monitoring devices to pick up the various wireless products that are in the environment, like printers, whatever, that tend to have relatively low intelligence, but can be connected wirelessly. And so now suddenly you've got multiple networks, multiple standards, all overlapping each other, often interfering with each other, and you can probably see it happen the poorest in medical installations, where then you also have to harden the equipment from these various wirelessly connected devices so they don't interfere with the medical devices trying to scan people. So it's a bit of a mess right now, largely because we have the effort to drive overall standards has not been driven well by government, and the end result is you get a lot of conflicts, a lot of interference, and we're nowhere near where we're going to be with regard to the number of devices in place. We're moving towards largely moving towards autonomous machines, including autonomous vehicles. That carries forward their own interconnect issues. At least they're talking about standards in terms of V2X. And some of those standards are making it through to automated machines and plant floors, but not consistently. So in the end, the Internet of Things largely is suffering from an overabundance of things growing very rapidly and an underfocus on creating common standards, common security rules, and a way to really approach this in a more holistic fashion so you don't end up with a huge mess of things that can't be managed or updated. So that's kind of where we are right now, and I'll let somebody else pick up from there.
Thank you, Professor Rob. We have our honorable speaker, Professor Dr. Mamun. Thank you for joining today's session. He is a founder of Private University Association of Bangladesh, as well as he is contributing for University Grant Commissions. And we have a strong request to you because this is our 529 episodes. People from around the world, very famous speakers from around the world, they contribute through World Talent Economy Forum. We have many good research initiative. Next year, February, we will launching our Nikola Tesla Technology Conference in India. Yes, we want to launch in Bangladesh if the private university associations support our initiative, and especially our request that if you share our content for our youth community, I'm sure it will be very helpful for all of the youth in Bangladesh. And I know in Bangladesh you have more than 100 private universities, and Bangladesh has more than 80 million people, those who are youth. Dr. Mamun, what you want to add for today's discussion, especially for IoT?
Thank you so much, Dr. Sharif and the other speakers. I was listening the speech from the Rob, and particularly you can share your opinion from your experience. But as I'm academic people, and already Dr. Sharif mentioned that how we can apply IoT things at our private university level. Before going to the main discussion, I'd like to share something that, as I'm from the School of Business, so I'm thinking from business perspective, how we can apply the IoT applications in our business field. So first of all, it could be like our connected vehicles. So autonomous vehicles are one of the most notable examples of the IoT in action. GPRS system, our vehicle tracking system. So it could be one of the best example. We can apply IoT in the traffic management, and we believe that if we could apply properly, particularly our subcontinent where the population is very high, the population density is very high, we can apply, we can get some benefit instead of using the human resource for the traffic management. We can apply this one for the smart grids. We can apply the smart grids. And you know that if you think about the environmental perspective, I think of my previous speaker, he started this discussion with environmental monitoring. IoT would be one of the leading tools for the environmental monitoring, particularly the waste management, how we can do this one. And if you think of the smart buildings, smart homes, and again, definitely can apply the IoT in order to ensure that security system and other issues. We can apply this on the smart cities. We can apply the IoT in the smart city. If we have a target to create the smart cities, then we can apply this one. So you can apply IoT, Internet of Things, in our supply chain management. You know that we are working the supply chain management for the supply to the customer end. So if we apply the IoT in the every end, we can apply the IoT in the supply end, factory end. You can apply the IoT in the distribution channel. You can apply the IoT in the retailer end. Definitely, the customer will get the benefit from the whole supply chain management based on IoT. Definitely, you can apply the IoT in our industrial, agricultural, commercial management. You know, agriculture is a very vital issue. So if we apply the IoT, then definitely we can enhance the efficiency and the effectiveness of our agriculture system. And what I said that, you know, that if you when you ask the IoT, the first of all you have to come in mind Google Home, come in mind that the Siri. So even the young boy, the childhood, the baby, they when they got up from the bed, they can start to think. So that means we can start at this kind of concept IoT in our personal life. But what I said that we can apply this IoT in the broader perspective in the different sector. We can apply in our education system. We can apply in our regulation system. We can apply to think of the smart cities. As I know that Dr. Sharif and he's working for this one smart cities. I believe that if you work the best on IoT in the smart cities, that will be more fruitful and effective. And that is my initial discussion about the IoT. I'll come back again at the last if I get the chance for Dr. Sharif. And now, Dr. Sharif, what he raised the issue that how we can apply this kind of technology advancement in our education system. Our subcontinent education system, we are a little bit slow in terms of technology advancement or adoption if you compare the like western country. But I believe the last few years, like particularly the last 5 to 10 years, our country Bangladesh, we are a little bit moving ahead than earlier stage. What I said that like the before the pandemic that we could not think about the like the smart class and something like that. Nowadays we are thinking how we can create that after the post-pandemic time, the smart class. Again, the question of the IoT, how we can apply. So we believe that we can apply this IoT thing, application in our private university sector, because the private university is a more in terms of the growth is better than a public university. So that is another opportunity for us. Maybe we can apply, and maybe the Sharif within his platform, he can add more values there, and I believe we can definitely like to contribute there. Thank you so much.
Thank you, Professor Mamun. Actually, we want more audience. We want more people, those who can get benefit from our content, from our contributions, and we ensure most of the high quality people like today's speakers. Uh, we always invite them. They join and they contribute, and their experience is priceless. And their advice and guideline and mentorship definitely valuable for the developing world. So I believe our private universities, if they can collaborate and we get chance to collaborate with them, maybe they can bring more valuable knowledge from developed world through this process. Professor David Smith, I want to know from you about this IoT, but beside that, I have one views because today you share one of the important uh, articles. Developing countries are being left behind in AI race, and that's problem for all of us. We are discussing about IoT. We have representative from Bangladesh, from India, and from this report, I find that South Asia, they are far more behind this kind of infrastructure and ecosystem. What is your advice? How we can improve this area?
Well, Sharif, thank you. And that article I shared this morning, I thought was an excellent one, and the feedback I'm getting on it. Because if you look at the leading types of technologies, there is a lead lag relationship to the many of the developing nations. You know, as you begin to look though at what the Internet of Things is, it has many, many different definitions as you look at it. And it really is around the concept of connecting to any device that's connected to the internet. And, this kind of reminds me back of what we saw in the early days of Star Trek and begin to use its examples there. But, if you really think about what the Internet of Thing is, it's really in three very different domains. And we see that being deployed. There is a manufacturing type domain, there's a personal domain, there's a domain that really looks at services to others, like in transportation and those. And you see those very much as you're looking at the industries it's leading in and what the advantages and disadvantages are. Some of the advantages is it lets you collect a whole lot more data. And the collecting the more data really helps you both in developing nations. Um, One of the other advantages is tracking. It helps you track things at home and business and around the world. it saves you time, it saves you money. But some of the real disadvantages there are in compatibility. There's no standard for tagging and monitoring with sensors, and it's there. There's a lot of complexity in it today, particularly as you look at uh, how it messages to others and the software that's used to for example, if I'm monitoring milk in the refrigerator and both myself and my partner receive a notice that the milk's bad, we probably will both buy it on the way home. So you see that privacy, security, safety, those are all concerns in the early stage of this technology. You know, as you see it there, it's early in its growth path, even though it the early precursors of the Internet of Things began in the 80s. My favorite example there was at the university where they rigged an Internet of Things sensor to a Coke machine to see if there were Cokes in it, and they rigged a sensor to the coffee machine to see if there was hot coffee there and notify them in their research labs. Those are the early precursors, but the Internet of Things will be trillions of dollars of marketplace. In fact, if you look at the market today, uh, in 2022, the market is supposed to be $478 billion in marketplace today. And it's going to be growing at about 27% a year. So it will be a very large market in the future, and a key one for us being able to apply the artificial intelligence, the machine learning, and the other tools we use. And it touches all parts of our lives. And that's why in both developing nations and developed nations, it's going to be such a game changer as we go forward. The ability to have data, knowledge, and being able to refer to things is very much there. You know, there's an example today that came out in the war in Ukraine, where one of the Russian oligarchs who had a home outside of Kiev saw the Russian troops come on his land there and begin to torture his servants, his staff there. They undressed him throughout. He called the Ukraine government and asked them to please bomb his estate there, based on the data he was seeing from his Internet of Things and the sensors. So it has this really wide range of usage. But there's so much to talk about, but that's a good feedback for me to let's get started. So thanks, Sharif.
Thank you, Professor. Mr. Kumar, I think right now you are in Scotland from India. You moved to Scotland. Congratulations. What you want to add for today's discussions and because World Talent Economy Forum, we are advocate for modern science, engineering, and technology, and we are working for developing world, definitely for India, for Bangladesh, for Malaysia. But my question is that what is your understanding a very good research ecosystem for IoT and how we can improve our ecosystem in South Asia?
Thank you, Sharif. Greetings to everybody. Yeah, I mean, as you rightly asked me, I'm currently working on a waste and resource which needs a lot of data. It has to be compiled. And I would say, like, though the data gathered, the IoT map, the environmental condition in the space territory, IoT becomes an observatory for everybody. So to fight against the climate change, it gives all the data. So now, I mean, we're sitting here, as you rightly said, in Southeast Asia, I can able to sense how much amount of waste has been generated in particular region. And we're trying to solve that problem by sitting here, giving the guidance as well as the machineries and equipments. And when we talk about um, the core equipments of IoT system, we use three form of equipments. I would say right now we use um, EPS 8266 IC based, or EPS 66, or if it's going to be even SIM based, everything is going to be like a core competency where we're able to put data in place and solve the right issues. I would say the environmental monitoring is very key here to make it sustainable. Um, so, not only in waste and resource management, we collect data in water accumulation, water stagnation, flood, and as the other speakers has very promptly mentioned about how we can support Ukraine in this scenario and what kind of data we can collect from them. And based on the population, we can spend our resources in the right amount and support them at the right time also. So in this, I mean, I'm more in the field using the IoT system. I can see the benefits out of it. And also, a lot of people thinking the IoT in other ways, like where they think about the day-to-day commutes, day-to-day operations, something like very, very basic, like as Mr. Professor David was mentioning, how hot is the coffee and how's the room temperature, and even we can sense our amount of fuel in the car. We can sense everything, and we can plan our a day and prior, and then we can work efficiently. So start from there till the climate change, as per the conditions, how much wind current, and what is the amount of water we have at the moment. So this can be estimated and we can predict. Through this data, we have come up with a value that in 2050, um, as per the population growth, in 2050, our population will be like 10 billion. And with that data, we can predict that we are running short of 38% in agricultural land. So it shows that we should prepare ourselves to produce more food for the future, but we have limited land surface on Earth. So that gives another idea of farming and agriculture in a vertical direction instead of horizontal planes. We have to do a vertical farming. So all this can be predicted upfront, and we can give a solution to it. So I was quite fascinated about this technology in on field as well as off field. So I'm looking forward to hear more information about IoT from the rest of the people.
Thank
Thank
you,
you, sir.
thank you. We have our excellent panelists from the industry. Definitely, we will learn more from our speakers. Mr. Joy Raman, you are also a climate change activist and you are a great scholar from India. Uh, what you want to add for IoT perspective, and if you share some of your experience from India uh, and Indian infrastructures and IoT related information with our audience, it will be helpful for us.
Thank you. Are you able to hear me?
Yes, now I can hear you. Hello.
Do you hear me? Good. IoT is a very interesting subject. From my observation, I am a novice in that. I'm not a technical fellow. I'm an accountant, and I specialize in management, corporate management. Here, come around, and we are looking at the opportunity that have been given to ordinary people. Like 7,000 crores is the revenue generated for individuals in YouTube in India. Google pays that much amount. That means the number of people, not necessarily about the experts or any particular field, but experts in talking certain things and able to convey certain messages, and a lot of subscribers coming. It could be art, it could be music, it could be literature, it could be politics, and various aspects of business ventures made possible because of the ordinary devices that had been given to individuals. So there had been a tremendous change for people for as a revenue generation part of it. I had submitted to MSME's ministry recently on draft policy. It had an amazing number of countries were suffering because MSMEs are not being coming to the area of expertise. They're all suffering a lot because in India alone, 110 million MSMEs are in existence. And these MSMEs are numbers in terms of about 5 to 10, 10 to 50, 100, MSME units. The same case with China. China also has got as many number of these categories. These SMEs have necessarily come about in terms of improving their financial stability. The financial stability for these MSMEs is a policy statement which had come out from the Bank of India and as well as from MSME Ministry from India. But we are not able to do that. We are not able to reach the target of policy accidents and policy politics. We have to avoid that. If we have to avoid that, the IoT and what manner the IoT is going to be systematized. The systematic approach to the big problem which is facing every country, like for example, Sri Lanka have gone into ruins because they were not able to project what is going to happen, particularly in agriculture part of it. They stopped the organic farming. I mean, they wanted to go for organic farming and stop their chemicals. They have ruined themselves. Ukraine problem is look at from, as I said, of Russia and all that. You are looking at the granary of Ukraine, which was producing a lot of wheat. And the wheat had been not able to, now they are not able to export. The wheat has become a problem. India has come about providing wheat or agriculture produce to various countries. Now, how we are going to improve upon it when there is a real critical area of attack? That requires what the I 4.0 industry says, not in terms of your advanced technology, but in terms of societal changes. If IoT is able to understand the societal changes and come out with a systematic idea of providing, benefit to the 110 million units, which is about nearly average about 5, we have about 550 million individuals, a part of the big society. Same case with India's agriculture. 650 million people who are associated with individuals. How are they going to get benefit out of this? IoT is a very important aspect. Even though there had been a benefit being seen on one side, the systematic approach toward the utilization of IoT in I 4.0, the fourth industrial revolution, as Klaus Schwab says, it is in that societal changes measurement. They must. That is my approach. I am doing it. Thank you.
Thank you. Thank you, Mr. Marshall. You are from industry. You have industrial experience. How actually IoT apply in Europe and in USA, and what kind of experience and case study you want to share with our audience?
Well, that's a very good question, Sharif, and I think a lot of the panelists have been able to articulate how they're using it. In our event, as anyone who has been following us on our programs with you knows, that we are in the climate restoration and climate repair approach, and we're using IoT in an industrial sense. So there is an industrial IoT. It's known by the acronym IIoT, not just IoT. So more acronyms for everybody to digest. So IIoT has been around for quite some time. We're applying it to our thermal conversion technology, which is known as pyrolysis, which is burning in the absence of oxygen. And we're scaled at a very large scale. The largest systems around the world are usually found in Finland, Sweden, Canada, and 3 companies in Hunan province, China, that manufacture systems that process about 10 metric tons of waste a day into this material known as biochar. We produce what we call elemental char because our systems are both 120 metric tons a day and convert not into 17%, but into 30 to 40% of char. The rest of it is thermal energy and syngas, otherwise known as pyrogas in Europe. And that is very usable with us because we also have another technology using IoT to measure and track what is going into the systems and what kind of energy we can generate, and also how clean the energy is so you can get carbon credits and that type of thing. So IoT, Industrial Internet of Things, is a very good tool. Some of the tools that we're using, we're partnered with people that provide cybersecurity and blockchain technology that allow us to do the IoT tracking and measurement. So Internet of Things for that we're using in industrial sense are the devices that are applied on the front end and the back end of our systems. And those produce data that is transformable into a lot of different opportunities. So that's what we're doing. And that's what I can speak to in our respect. In fact, right now, we're being approached by the United Nations. We meet 14 of the 17 SDGs, Sustainability Development Goals of the UN. It's a big deal in Europe. Not so much in the United States. I don't think they care about it as much, but certainly in Europe, it's a big issue. And so I think we're able to meet those goals, and those goals are all wrapped around, I would say, two major components: sustainability, like some of our speakers are involved with, and also the Internet of Things, the technology that measures and gives the data back so that you can actually determine, are you successfully implementing the Sustainability Development Goals? Can you measure those? So a lot of the devices that we're using are attached to our technology and are used to measure and track not just the Sustainability Development Goals, but also the credits that we'll receive for sequestering carbon and reducing greenhouse gas emissions. Hopefully that answers the question.
Thank you, Mr. Marshall. Professor Donald, you are also from the area of Silicon Valley. You have experience from Stanford University as a fellow, and you run a business incubators. You have a strongly engagement with the startup ecosystem. What experience you want to share for our audience for IoT?
Well, I think that people have given good examples of using IoT and covered what it basically is. It's that as the internet, as devices have gotten smaller and smaller, and our ability to make internet-enabled devices more portable, we're able to use them for all kinds of purposes. For instance, jet engines right now have something like 50,000 sensors in them that monitor every aspect of what they're doing, so that you know if something's going wrong with your jet engine when you're flying, which is wonderful. And people talked about various kinds of devices where you're monitoring. What I'd like to talk about a little bit is something that almost everyone has said, and it is incredibly important, which is that collecting data for the sake of collecting data is kind of a fool's errand. Because I came across this wonderful quote from Charles Darwin, actually, a while ago. And of course, there we go. He said, about 30 years ago, there was much talk that geologists ought only to observe and not theorize. I remember someone saying that at this rate, a man might as well go into a gravel pit and count the pebbles and describe their colors. How odd it is that everyone should not see that all observation must be for or against some view if it's to be of any service. In other words, the point of the matter is, it's gotten very, very common for people to say basically, well, if we just have enough data, we're going to be able to solve this problem: artificial intelligence, climate change, whatever particular problem that we're hoping to solve. And why? How? I mean, what good is it? We're going to the gravel pit and counting gravel and cataloging its color and size. It's really, we're not doing anything. So I appreciate what Marshall was saying about the fact that he is collecting data to compare it to measurable goals. IoT could be IoT or any sort of data collection is valuable if if what it's doing is testing hypotheses that you've made against some sort of theory or view of the world that you're trying to test. And so, what has to happen, not just in the developing country, we're terrible at it in the United States. We've gotten into this whole entire thing where just collecting the data is the thing. So big data, artificial intelligence, and all these kinds of things have gotten to be something in themselves. And in a lot of cases, they don't really do anything particularly. They find out they can be used to sell you things and a few other things, but they don't provide a particular lot of value, and they've kind of reached a wall in some ways. I mean, they're very good in some areas, but they've never been extended into other areas. We don't really know how to do it. So I think with IoT or anything else, the way that that you kind of have to take a step back and look at our educational view itself, and we all need to learn to take a scientific view of whatever thing that we're trying to work on. So if it's climate change, certainly sustainable development goals are a very valuable target. But are they the right target? Are they the best target? Did we right now sit down and decide exactly what the perfect thing to do was, and that's it, case closed? We don't need to change anything. No, we're going to have to keep learning and keep making changes and take the hypotheses that we've made, realize that some things that we tried didn't work, and then keep trying new things and modifying what we do. So if a developing country has the ability, what happens is that as you start investing money in something, then more and more people get trained in doing something a certain way. More and more money spent to doing it that certain way. More and more equipment is bought. Books are written. People start to teach, and then nobody wants to change things. But in order to be able to move forward, you have to be able to be flexible and be able to change. And so developing countries don't have, that's what's called path dependencies. They don't have the kinds of path dependencies that the rest of that we have. And so when you're looking at Internet of Things, it's most valuable to look at it as a way of getting feedback and testing hypotheses about everything that you're every problem that you're trying to solve.
Thank you, Professor Donald. Professor Dr. Mamoon, can you hear me? Yes.
Yes.
I want to bring some valuable points to you. Naturally, I do not like to go for complaint, but we are representing youth communities from developing world. That's why I'm sharing practical experience, because from Bangladesh, from India, from developing world, regularly we get complaint for two things, because we working for quality education, we working for knowledge economy. uh, uh, they have complained for these things, and some point the youth communities, those who trying to develop this startup ecosystem, they are closely working with us. We give them support, necessary support, for their research, for their problem identification, some point for their investment, and their market development. Their major complaint, our policymakers, again, our policymakers, those who develop policy for developing this uh, startup or for developing digital Bangladesh policy, uh, their level of understanding about technology must need to improve. I'm sorry, because personally I engage with this ecosystem, especially those who taking policy, developing policy. I have record for April. I attend in the ICT divisions. I attend in some of their interview procedures. The senior person, those who actually taking initiative from the government to develop this digital Bangladesh. It's so frustrating how they handle these technological views and what is their understanding about technology, how we can improve this point. Second things, they ask me translate my research paper in Bangla. I do not know. I'm Bangladeshi. I do not know how to translate these kind of things. Even from my views, yes, with my PhD and other degrees and some experience from developed world high quality research lab, if I fail, how come a undergraduate students they actually getting support from the ecosystem and what's actually going on, how we can improve? I'm not complaining. My objective, how we can improve the situation, how we can improve the situation of policymakers.
Thank you so much. Very good question you raised. We like to start in this way. Sorry, can you hear me?
Yes, yes, yes.
Yes.
First of all, I like to start in this way. You just think we are talking about the artificial intelligence, we are talking about the Industrial Revolution 4.0, we are talking about the blockchain, environmental issues, sustainability, we are talking about this kind of, I would say that technology advanced topics. But unfortunately, still we could not launch this kind of course in our curriculum, because our curriculum, which we are using the curriculum, this curriculum produced for a long time ago, suppose 10 years before, say, and now you have to revise the curriculum so that it will be the institutionalized. Say now, if you like to launch the IoT courses, how you can apply this one, then probably with our regulatory body, particularly our regulatory body, suppose University Grants Commission, they have some official procedures, which is very bureaucratic process. And now we need someone who will expedite the process.
Exactly.
Again, we need some dynamic person, those who will think out of the box. We know that this is our system. We know that because that we need the like artificial intelligence course, but we cannot launch it. We
Exactly.
need the course of the blockchain. We need the course of the Industrial Revolution 4.0. We need that like you're talking about the like ecosystem and the environmental issues and other something. But we have to incorporate this one in our coursework academically, institutionalized. But what I said that our regulatory body, the still is the analog system they are following. But I believe it is changing. You know, our main positive side is that our honorable Prime Minister, she's very dynamic. But unfortunately, beside her, the other people, those who work for the next level of the leadership, they're still in the analog system. And sometimes their attitude, what you said, it seems to you that they're surviving like the 2000 level. Now the 2022, we are thinking about how we can survive after the post-pandemic. So our technological advance we have to apply. And now, second thing, what you asked me, how we can use this kind of startup ecosystem and other something. Again, go back to that concept. What I said that out of the box thinking, mindset change. Some people they think that undergraduate level student, no, he cannot do anything. Why he has to think of the startup? He can do this kind of startup after the undergraduation. So that is the mindset. But you know that last week I delivered the one lecture in the Taylor's University in Malaysia. This is the top ranking private university in Malaysia. It was surprising that they work on that research, that the topic of the research innovation in the undergraduate level. It is very interesting thing is that they are trying to adopt the research ideology in the undergraduate level. Whereas in our subcontinental culture, the undergraduate level research, no need to think. So what you say, the startup, this kind of technology advancement, still our undergraduate students, they are not aware about this kind of courses. So I believe that it's a time for us to go for the change for the mindset. We need some young leaders like the Dr. Sharif and others. But again, I like to request on the Dr. Sharif that we should be optimistic, and
Yeah.
so that we
No,
can
no.
work with our this kind of analog people, and we try
Yeah.
to adopt how we can modify, how we can go to the next level. And I
Yes.
believe, inshallah, it is not very difficult because what I said that now time is changing, situation changing. Now we understood. Once a time, 20 years before, we could not think this kind of webinar in our country. 20 years before, we could not think this kind of like Zoom meeting, webinar, or something like that. We think that it's online. Online is not useful. But we assume during the last 2 years, pandemic time, it's very important. At least we have to continue, right? So I believe that we have to go to the next level of the technology advancement, but we need some good leaders. It will come from the top, both side, academic side as well as on the corporate side, and then
Thank
hopefully
you.
it will be changed. Thank you
Thank
so
you.
much.
This is the realistic things I want to bring in the table, and regularly I'm getting experience from different ecosystem, uh, and we need to work together. One thing I can ensure that World Talent Economy Forum, our board of advisor, we ensure the best of the best resources from around the world. You can check all of the scholars' background and their Wikipedias and their all of the informations. And I'm sure we should have I believe that when we utilize these resources properly, we connect the right kind of people for our local ecosystem development. Then the real improvement actually come. So that is one of the important aspect I believe that we can take and we can work together. Professor Rob, you have experience to work for many large corporations like Microsoft, IBM, Cisco. Uh,
Yeah.
how they think about this problem? They can take any realistic initiative for doing collaborations, especially I believe the developing nations major problems, the policy maker, the decision makers. First we have to train these people. I'm very honest with you. Second thing, our youth are very dynamic. They regularly use online things, online content, social media. They're very dynamic. So how we can minimize the gap and give a proper directions to the developing nations and ultimately get the result, how we can work together and bring real result.
Well, first you've got to create and fund the effort to do that. It can't be a volunteer thing. If you want to create liaisons with industry, the liaisons have to remain pretty consistent because they have to know who to talk to and they have to develop relationships with the people they're going to work with.
Just one point, Professor. Sorry, I'm interrupting. I just want to add for your kind information. Professor Mamun actually correct. Our Prime Minister of Bangladesh, she is very dynamic. And I know for startup ecosystem development, Bangladesh invests around $5 billion. So they have money. I do not want to say that no, they are looking. Yes. So how we can?
Money is only one of the issues that has to be addressed. The other is staffing and consistency. Often administrations change in any government, and efforts like this tend to wax and wane with whatever administration's in place. And so industry doesn't trust them. And so because you can loop in tightly, spend a lot of money creating the relationship, and then the next election comes through and suddenly the administration has lost interest, and all that effort you put into it has been wasted. Or the new administration comes in and they want to work with a different company set because the other company set has contributed to whatever the election was. So there has to be separate from the political process, an organization that is predominantly focused on working with industry, and that organization has to remain consistent, has to remain funded to a degree that the industry can trust that it will live up to its part of any commitment. The Cisco probably has the strongest platform to work with governments. It was designed specifically to work with governments. They work and help create the liaison component first, and they remain very focused on the end result that the government organization calls out, where a lot of other companies predominantly do this to move hardware and software, and that becomes kind of problematic long term. Because if you're just trying to sell software and hardware, that means some percentage of some percentage of the engagements are misprovisioned. So it's the wrong stuff being applied to the wrong problem. So that's why the Cisco model is so critical. And I would probably start with somebody like them that does it well, and then cookie cutter the success once it emerges to other companies and other efforts. The Cisco, of course, is predominantly focused on connectivity and networking, since that's their strength. That's also something to realize is not every vendor is good at doing everything. You want to choose the vendor to partner with that is expert on the technology that you want to use to solve the problem. And by the way, that does mean you have to develop a competence in that technology first. And going to any vendor with lacking competence and asking for a solution is asking the vendor to step up and not only understand what they do, but understand what you need. And that's very difficult from the get-go. That kind of relationship can emerge over time once the vendor and the government become well engaged. And so they understand each other, they understand their strengths, their weaknesses, and particularly their limitations. And then they know when to ask for other companies to come in, for other government organizations to come in. So the goal is always focused on the successful outcome of the project, and not so much focused on maximizing a company's revenue or making one political party look better than the other. That's the nuance to this effort, but it can be done. Now, if I can move to the IoT stuff a little bit, the biggest thing that's coming with regard to IoT is the metaverse. The reason that is because the metaverse's largest usage model outside of entertainment and gaming is simulation, and to accurately simulate the world, you have to accurately instrument it. Donald was right. The industry was doing something pretty stupid when it went through the big data decade, but that was last decade, and that was largely driven by the storage industry. And you can imagine why. If you're selling storage, then you really like the idea of people capturing massive amounts of data, and whether they can do anything with it is not your problem, because you're just storage. You're not processing. But that kind of petered out a few years back. Now we're talking about using synthesized data, even for deep learning, moving intelligence to the edges and cutting down on the traffic and the amount of data in transport in order to reach decisions more quickly and while preserving accuracy. Now, I want to point out that when using synthesized data, there is a high risk of inaccuracy and bias, because you're not sending the full data stream, and whatever decisions are being made with regard to the data being collected by the IoT devices that are placed remotely are going to have a direct representation of the decisions that are made by the central processors that are getting that synthesized data. So it dramatically reduces the time needed for deep learning AI, but the risk is it can also introduce bias. The example I've used in the past is the one out of Amazon, where they had a major problem with regard to delayed deliveries. And Amazon's probably the most instrumented company of its type in the world. So the amount of data they collect is unprecedented, yet their systems were not showing the problem. The problem was being surfaced by customers who were getting their products too late. And the reason why they couldn't figure it out is because they'd made a decision at their centralized distribution centers not to monitor endpoint distribution, because those distribution centers weren't supposed to do that. They only distributed to endpoint distributors who then did the last mile distribution. So in theory, their determination of not collecting detailed distribution data was a good one, but only if that policy where the centralized distribution centers weren't distributing was followed. But one distribution center manager had decided to actually, because it seemed to him to be quicker, why distribute to an endpoint distribution center in his own region when he thought he could distribute much more quickly himself, but he couldn't. The process they implemented was inefficient, but because it wasn't being captured by the synthesized model, the centralized services didn't pick it up, and so they were unaware of the problem except through complaint. And it required a forensic analysis firm to come in and take a look at the core data, actually analyze the source data that was being missed, and to discover the problem. It was anything from a trivial model to be solved. So as we move to these synthesized data data collection models, which is where the industry is moving now, reduce the amount of data so that it can be analyzed. Because Donald was right. When you have massive amounts of data, it overwhelms your ability to analyze it real time. And so you get an answer, in weeks or months when you need the answer in minutes or hours, especially if you're monitoring for a security breach of any type, either digital or physical. So then a lot of these IoT systems are employed for security. So it does showcase we've moved from the world that Donald talked about, but we've replaced one problem with another, the problem of massive amounts of data to the increased possibility of data bias through the synthesis of data, and that could be problematic going forward, and especially as we move to advanced AIs. We're now moving to broad AIs from specialized AIs, and that potentially exacerbates the problem of bias, because you're not seeing the stuff that might indicate that bias exists. And so that does mean we're still going to have to figure a way to audit on a regular basis the full data set and compare those results to what was captured through synthesis in order to identify and eliminate bias, to ensure that these increasingly intelligent machines are doing things intelligently and not doing more harm than good. So this is a fascinating area with huge amounts of opportunity for jobs in data collection, in sensor development, in localized AI, in centralized AI, in data transport, and in data and repository security. So all of those things, and I've probably left out some categories, are showcase opportunities in the IoT environment as it continues to mature. This is an area that probably will never be fully mature. As others have pointed out, this is going to require constant development, oversight, and audit. And one of the large dangers with any process like this is people become complacent. They think just because something has always worked, it always will work. But if the environments around the sensors change, that data synthesis model will have to change with all of those sensors to take that into account. Otherwise, bias will be introduced, not through programming or the nature of the initial sensor, but the change in the environment around that sensor. And so as we move to large constructs like Earth 2, which is going to require a massive amount of sensors, maybe even down to that gravel counting sensors that Donald pointed out, because we do have the concept of the butterfly effect, where you need to look at very small items of change all over the globe to indicate what might be a large change in another part of the globe. Earth 2, if you don't know, is going to be the largest and most accurate weather forecasting model ever attempted. And the more data and the more sensors, the more accurate it will become. But it's going to require a massive amount of data synthesis, because data transport and collection and repositories and analysis are going to become huge problems if that's not done. And once again, as we're removing bias and doing collection, that's going to introduce unique kinds of bias going forward. So but if we can do Earth 2, there's very little that we won't be able to do in terms of being able to project future events from data that can be captured. So it's a long-term project, one of the most aggressive projects ever done, and it'll have broad implications for analysis and being able to develop products and projects through simulation that we've never been able to do before. So it's going to be an amazing thing. And another topic we might consider in the future is how we're going to deal with the human digital twins that will be placed in that digital world, whether they'll be who will own them, and whether they'll have rights and liberties as well. So an interesting thing we're developing long term, but for a topic for another time, and we'll move on.
Thank you, Professor Rob. Definitely next week we will bring this topic for discussion. Professor David Smith, what is your advice and guideline? Very interesting discussion today.
I really love the backside of this one with what we're doing. The Earth 2 concept is one that's going to be really very big as we go forward, and how we're going to work with it. And how we're going to work with it. The latency in the network is going to be one of the key elements to deal with. And latency is going to be a key element in any network that we deal with Internet of Things. And when we're trying to begin to move to real-time sensing, real-time monitoring, and real-time reaction, we really have to look at the network and the network effects of this, because they're going to help us dictate on whether we're doing a system that can be in control and react real time, or whether this is an informational network of Internet of Things. And it's really going there. But to me, as we look at the future of the Internet of Things, it's limited only by the human imagination. And we hope that as we look at the human imagination, many of these, like what Rob was talking about, benefit humankind and work there. But, we're seeing tons of industry applications. I have a new car. I'm amazed at the sensors that are used in it and how it can connect and how we can go back and use those in a broader context. We see it used in healthcare every day. I was in a discussion yesterday where a diverse group of Internet of Things sensors are going to change the way home healthcare is delivered for senior citizens and be a real-time monitoring and reaction. But those are some of the possibilities. Now, as we talk often in these, a lot of opportunities still for entrepreneurship with Internet of Things. Because so much we can do with it, we're still imagining. A lot of opportunities to create new companies, to put new places in it. Virginia in the comments is talking about disruptors. Internet of Things, because of the digital ubiquity of our internet, can be disruptors anywhere in the world. And we're seeing that today very much so. We're seeing different devices used that can be geolocated and tell us ground truth that in the past was hard to understand. But a disruptor, as Virginia is using it in the comments, really is one where it's going to be able to be part of a larger system. And she talks about putting errors in it and predicting errors, very much so, but it's also going to be able to help us understand change. We talked yesterday about climate change, and as Rob talked about, it's thing there. But if I look in agriculture, it's Internet of Things going to revolutionize agriculture and how we treat growing plants and things. It's going to really look at the ability to revolutionize transportation. It's already revolutionizing manufacturing, retail, many of the other parts of our life. And the possibilities, as we said, are endless. And the governments need to begin to understand there is not a good standard, as I talked about earlier. So industry and government need to come together and look at standards both for interconnectivity, but also for privacy and security. Last year, in the United States, NIST was tasked with putting together a set of privacy rules and security rules for Internet of Things in the United States. That is still a work in progress. And we need to do the same thing internationally because of the pervasiveness of Internet of Things. Because most Internet of Things are open sensors that if I go and spend enough time sniffing the network, I can discover them, I can intercept them, and I can use the data. And that might be really good if I'm looking at climate change, or it might be really bad if it's a sensor used while I'm driving and I interject error into it and cause an accident. So a lot of work left to be done there. The application sets are broad. The market growth is huge. And it's predicted that by the end of 2022, there will be 41 billion Internet of Things devices in use around the globe. So it is a very large set of information. and one that is going to give a lot of opportunities and a lot of challenges. So, Sharif, thank you.
Thank you, Professor David Smith. Mr. Kumar, what's your concluding remarks for today?
Today I've learned so much, a lot of information to compile in my head. And I mean, every day we used to debate about different technologies, which technology serves better in terms of environment or fight against climate change. Always data comes first. So even yesterday when we are talking about whether electric car or a hydrogen car, we take a lot of data in the industry. I mean, in the industry, in the university, they throw a lot of information on both aspects, the benefits and the demerits. But the data which gives a clarity for us, which one to go forward for a longer run. And most important thing, developing nations like India, Bangladesh, and Southeast Asian countries, whatever the Western countries have done, they collected so much amount of data. Now the IoT has come into place, and which gives a clarity how to collect data, in what format, what kind of system we should follow. So that gives a better clarity and better edge for us. So we put those stuff in those arena and then sort it out, and now we can take a clear cut idea whether we need an hydrogen car for a country or an electric car, because which kind of infrastructure we need to build up. So all this comes into play and gives a very much a clarity to us to go forward. So not only in vehicle industry, I also talk about energy or food, especially agriculture. As I mentioned earlier, we all we have is 23.6 million square miles of agricultural land we have in planet Earth. So in another 30 years, we're gonna running short of land for growing crops for the entire population. So that can be predicted upfront, and we can plan accordingly, and we can position ourselves where we need to do and what we need to do. So I would say this is a great boon for us, and we want to implement this system in a lot of other areas to have a better clarity and understanding to support the SDG goals. So, yeah, and
Thank you.
that summarizes everything for me. And thank you so much, Sharif, for this
Thank
wonderful
you.
opportunity.
Thank you. Mr. Jayaraman, what's your concluding remarks for today?
Well, it's very interesting, and what Kumar said about the EV or hydrogen sort of thing. How many number of people are working on that in the world? I have gone into about nearly 10 podcast episodes covering almost all the subject matter which we had discussed earlier. The transition to green economy, MSMEs, IMF, accounting for climate change, accounting for dreams, accounting for, corporate governance. So these 10 episodes, which I had already published, I'm coming out with a book, which has got a common thread. The common thread is that, which the publishing this particular book is in terms of the practice of unified field theory of management, corporate management. The unified field theory of which was brought up by Einstein is a connection between two. One is physics, another is metaphysics. In physics, we know what we are discussing, like Mark said about whether vehicle or the Cisco experiences, and what Marshall had been talking about, is infinite. Whereas what is finite is the number of people. The number of people is only 10 billion by 2050. Today is about 7 billion. You bring that as a denominator. If you look at the physics, you are looking at energy is a liberated matter, which we show in P&L and balance sheet. We can cover everything in every company. Then matter is the one which is waiting for the energy to be put through. It is there in raw materials form, it is there in various forms. And the third one is that matter when collides with antimatter, it forms energy. That is our source. That energy is 10 billion in 23. We have only energy in 50. So if you bring that as a return on intangible, we are in a position to find out, locate every area of management. The corporate management becomes very simple actually. The number of downloads which I had to these 10 episodes was about 230,000 downloads. Very many countries all over the world have downloaded. One of the one which I had picked up is Finland and China. So I'm analyzing all these data. When you want the dynamic database system, which we have put, I have one of the podcast series is dynamic database system. We should not talk about the energy as a liberated matter, which we are showing dimension. What we had to put that is that identify what is where is matter where energy is not being controlled. It is simple. Connecting these physics and metaphysics, we are in a position to identify every person who is involved with EV and hydrogen carbon. How we are that? You are looking at Kumar is looking only at his own area of data. That data, what I am trying to do that is that FAO or World Bank but written one thing is how to reach the 1 trillion agriculture economy. Connect the produce of a single farmer to the data that you are going to show in FAO, worldwide data in each and every item. What I have realized and what I have analyzed, the data is about 3 years old. When 1.5 trillion economy for Gujarat state domestic product, which I had done, we could not get the data. This is the same case with the Indian economy. Minimum 3 years work. What is there in 2018 is what we are trying to get the data. Wanting to get this today in 2022, we will get only 2025. So the denominator, if we can change, which is numbers in terms of individuals who are going to make the contribution, and the effort that you have is called what I call the EPP. It's the effort per person. How it is being done can be calculated. That's what I would like to impress upon. Thank you.
Thank you, sir. Mr. Marshall, what's your concluding remarks for today?
Well, thank you, Sharif. I think this is an excellent panel. I like all the comments of all the speakers to date. One of the things that we're running into with what we're doing with IoT, Industrial Internet of Things, is that essentially we're using the data to do several things. One is to, as we said, measure results. Also track what is working and what is not working. It's a science, but it's also a craft. What do I mean by that? I mean by the fact that when you convert waste into elemental chars, formulated chars, syngas or pyrogas, as they call it in Europe, or even thermal energy, or other products such as wood vinegar, you need to be able to understand what quality of material you're generating at the end of the day. And you need consistency of product for the off-takers to purchase, and also to track whether you're going to get a carbon credit off of it or not, and whether you're adding to the problem of the climate crisis or you're reducing the climate crisis. So the industrial Internet of Things, as I described in my first round, are tools, physical tools that are using us to measure what's going on and how to keep track of things with blockchain and other data tools. And we're doing that as we speak, and it's really important to understand that this is going to grow exponentially at a very exponential rate. And the reason is because the climate crisis is here and now, and countries around the world, believe it or not, are not paying attention to it, because big industries such as big ag, big chem, and big oil and gas and coal are trying to maintain their handle on the revenue they generate. which is okay. But on the other hand, if it's contributing to pollution and to health issues around the world, we need to address it. And also, we need to reduce the uh, temperature from to at least to 1.5 degrees centigrade within a short period of time. And in order to do that, we got to take these stranded assets, such as oil and gas and coal, and we can use them. We can get the big companies to participate, and they can actually generate more revenue and more profits for their shareholders by going through the route of clean technology and renewables. Not just for energy, but also for cleaning up the environmental impacts that have been caused over the last 200 years. So now is the time to take action. Now is the time, especially in the developing world. So, Sharif, your point about what's going on in Malaysia and what's going on in India, what's going on in Bangladesh, what's going on in sub-Saharan Africa, we need to act now because they are not the cause of most of this pollution, but they are they're the victims in a large part of these types of pollutions that are occurring around the earth. So we need to take action now. Everybody on this panel has something to contribute, and I wholeheartedly support the World Talent Economy Forum, and I ask everybody on this panel to join in with the World Talent Economy Forum under Sharif to actually participate and take action, practical action now to reduce these environmental impacts. It can be done. The technologies exist. The issue is we are running into both political and financial and other constraints, but those can be overcome. And we're working on that as we speak. Our group is pursuing a large scale European Union climate bond under the waste management taxonomy, which dictates that you turn brownfields as defined in Europe, not in India or the United States or Canada or any other part of the world under the EU definition of a brownfield, into 100% greenfield. And you don't get the bond if you do 99.9%. You got to demonstrate that you can be 100% conversion. We've done that. We've received our condition of fit from the EU, and we're pursuing that. And we can do that in other parts of the world. Though we are manufacturing our technology in Italy and other parts of Europe, our joint ventures are not have to be in Europe. They can be right now. We have 9 of them, and most of them are in the Western Hemisphere. So where we do the waste haulers and the landfill operators don't have to be in the EU to participate. That means waste haulers and landfill operators in Malaysia, in sub-Saharan Africa, in other third world countries can benefit from this. So my approach to this and our approach from our group is to participate together. We need all hands on deck, and that's why we're working together with the World Talent Economy Forum to make this happen. Time is of the essence. Whether you like it or not, there's a climate clock ticking down in New York City. It's not the clock that ticks down for New Year's. It's the one at 14th Street Union Square. Go look it up. It's on the internet. You can see it live, and you can see it streaming, and it doesn't give us a lot of time. And it's based upon science, not based upon some fictitious data or something. And a lot of the science that it's based upon is on industrial Internet of Things technology and AI technology that allows us to measure what's going on around the Earth, especially with the melting of glaciers and other environmental aspects that actually impact Indonesia, Malaysia, and the Southern Hemisphere countries, including Australia. Now is the time to act. So I request and send out this invitation to everyone to collaborate and get together and make this happen. Thank you, Sharif.
Thank you. Thank you, Mr. Marshall, for your excellent contributions. One thing I want to add, this dialogue also part of action. What is the problem around the world? We do not have enough trust. With this dialogue from developing world and developed world, we are developing trust, right? So developing trust also very important. What we are observing in Ukraine, uh, Russia and Ukraine, they go for war. If Putin and Zelensky they sit together, they go for open dialogue, there is a possibility that we can save more people life. So going for dialogue, understanding the different culture, go for open discussions, This is also part of action. Do not try to ignore it. This is also real action we are taking. So when we have a real trust, what we are trying to achieve through World Talent Economic Forum, and I believe already we achieve it, because many government, many university today, you see that private university, I think they are representing more than 100 university, private university, more than 50 million youth. So this way, we are engaging with the communities and we can take more practical work. If you always say action, 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 but you do not time or real understanding or real preparations to the peoples, and you cannot make a real relationship with the developing world, most of the things you cannot go for the positive progressions. So better give time when the developing world or the any part of the people, they can understand you, your action, understand your demand. Ultimately, they will take initiative. Now I do not have to go for anywhere. People come and they said, yes, this is the right place, and we can work with you. So this dialogue also important. This is also part of real actions, and through the real actions, through this dialogue, we can solve many problems. And because of this openness, lack of openness, actually we are we are losing many things. So better we sit together, we make a real relationship, and we are organizing the best possible and transparent open dialogue space for the developed world and developing world, and hopefully it will be a very effective action for improvement. Professor Donald, what's your concluding remarks for today?
I want to clear up a misunderstanding, which is I was not in any way talking about the data that's stored on computers. Whether the data is processed at the edge or on disk is irrelevant to what I was saying. The artificial intelligence there's not going to be general artificial intelligence, and the reason is because computers are so incredibly bad at logic. Now, that sounds a little weird because all computers do is logic, but there's three kinds of logic. There's deduction, induction, and abduction. And computers are basically, the core is deductive logic. Inductive logic is what we've gotten so excited about when we use deep learning. What it basically is, it's counting gravel. That's what deep learning does, is it counts gravel. And there's nothing that we're going to be able to, there's nothing that a deep learning system can analyze that isn't in the data. I mean, that's all it does, is it looks at data. And the solutions to the problems that we need aren't necessarily going to be, or probably, I mean, are probably not in the data. I love what some of the people are doing, is that they're using the data to get feedback, to be able to understand if the ideas that they've developed are actually making a difference and changing. I mean, that's important. We have to get feedback. We have to be able to look at what we're doing and be able to understand. But we have to tell the computers what data we want to look at, and we have to understand why. We can't just look at it random, just look at it and hope that magically we're going to see these patterns in it. That's not going to happen. I want to just point out what abduction is. Abduction is guessing. It's the basis of scientific method. How do you create hypotheses? Computers can't do that. Computers can't guess that something might work, and they can't even guess. They can't even guess simple linguistic things like being able to identify pronouns correctly in a sentence. And there's no theory on how to do that. We don't even have. We've worked on this for more than 100 years, and there's no theory that on how that works. So there's no hope on the horizon that we're going to have general artificial intelligence. And so I caution people a little bit about putting too much faith in technology itself. I love the idea of I love Internet of Things. I've seen some incredible uses for it. Like I know some people who've developed a thing that can sniff garbage cans to find out, or recycling bins to find out if there's organic material in it, because you don't want organic material in recycling bins. And so it will, help people be able. You get confused. Which bin am I supposed to put this in? And they developed technology so that it'll help you figure out which bin that you're supposed to put your recycling in, so it gets into the right place, so that you don't have to throw it. It doesn't have to go in the landfill. So there's countless uses for it. But remember that ultimately the problems that we have and the problems that we have to solve are human problems. Computers can't have problems. They don't get up in the morning wanting to do something. They don't run into issues that bother them. They don't lay awake at night worrying about things. They don't have problems. They don't have goals. Nothing. Those are all human things that you need to work on. And so I think that we get really siloed, and we get very, very excited about writing the next algorithm that can analyze data and create some sort of exciting model that can find some regularity in the data. But that's kind of not what we need to really solve these problems and make the world a better place. So Internet of Things is exciting, and it's incredibly important to be able to understand it. But you need to really understand that it's a tool and understand where it sits in the hierarchy of things. And so I highly recommend to everybody to take a bigger picture.
Thank you. This is excellent discussion. I think that we get a lot of informations, very realistic guidelines. We get a real problem and some real solution from our speakers. I want to give special thanks to Professor Rob, Professor David Smith, Mr. Joy Rahman, Mr. Marshall, Professor in Practice from Industry, Professor Donald, for your continuous support for World Talent Economy Forum. I request all of our audience, please share our content with your government, with your corporation, with academia. I'm sure you will get very good strategic guideline from this open dialogue. Thank you everyone for joining today's session. Thank you. Bye-bye and take care.